Welcome to another deep dive. Today we're going to be looking at something really interesting. It's quantum entanglement. It's a topic that's kind of mind-boggling, not just for physicists, but for anyone who really starts thinking about the philosophical implications of it all.
Yeah, what's really fascinating about quantum entanglement is that it forces us to sort of rethink our basic assumptions about reality, like what is real?
Yeah.
And how do we know what we know? And we're going to be kind of digging into these questions today. Our main source is going to be the Stanford Encyclopedia of Philosophy's entry on quantum entanglement and information.
So let's get started with like a really simple explanation of what quantum entanglement is. Imagine two particles that could be anything, right? Like electrons, photons, whatever.
Right.
They're linked in a way that even if you separate them, like across a room or across galaxies, their fates are still connected.
Yeah, and that's a good starting point. But the really weird part is that in the quantum world, it's not just that they're correlated, it's that when you measure one of them, it instantaneously influences the state of the other one.
Okay, so let me just jump in here for a second. This is what Einstein called spooky action at a distance, right?
Exactly. He thought it was impossible, that there had to be some kind of hidden variable, some missing piece of the puzzle that we just hadn't figured out yet.
Yeah, because it just seems to completely contradict our everyday experience of cause and effect. Like, how can something happening over here instantly affect something over there without any kind of signal traveling between them?
Right. And, this is really a fundamental challenge to our ideas about locality, the idea that things can only be directly influenced by their immediate surroundings.
So Einstein and his buddies, Podolsky and Rosen, they basically said, look, the universe can't possibly be that weird. There has to be some kind of explanation that preserves our common sense notions of reality.
Yeah, they were really committed to the idea that everything has definite properties, even if we're not looking at them, and that things can only influence each other through local interactions. But entanglement kind of throws a wrench into all of that.
Okay, so we've got Einstein over here saying, no way, this is too spooky. And then we've got quantum mechanics saying, oh yeah, the universe is way weirder than you think. And it's not just some abstract mathematical theory. Experiments have actually shown that this entanglement thing is real.
Yeah, and that's where things start to get really interesting because it forces us to confront the possibility that reality is fundamentally different from how we perceive it.
And one of the guys who really struggled with this was Erwin Schrödinger, the guy with the cat.
Yeah, Schrödinger's cat. That's the famous thought experiment that illustrates just how bizarre quantum mechanics can be.
So how does Schrödinger's cat relate to this whole entanglement thing?
Well, Schrödinger was actually the one who coined the term entanglement, and he was really bothered by the implications of it. He realized that if you have two entangled particles, you can't describe the state of one without referring to the state of the other.
So it's like knowing that two numbers add up to 10, but you don't know what the individual numbers are.
Exactly. And it's not just that we don't know, it's that the individual numbers might not even have definite values until we measure them. And the act of measuring one particle instantly determines the value of the other, even if they're miles apart.
Okay, so that's pretty weird. But how do we know that it's not just some theoretical quirk? How do we know that this spookiness is actually real?
Well, that's where John Bell comes in. He came up with a way to actually test this experimentally. He said, if Einstein was right, then there should be certain limits on how correlated the measurements of two entangled particles can be. But if quantum mechanics was right, those limits could be broken.
So Bell basically said, let's put this to the test and see who's right. What happened?
Well, a bunch of experiments were done, starting in the 1980s, and they all showed that the correlations between entangled particles could actually violate Bell's limits.
So it turns out the universe is actually spookier than Einstein thought.
Yeah, it seems that way, and that's a pretty big deal because it means that our everyday intuitions about how the world works might be fundamentally flawed.
That's a pretty heavy thought to leave us on for now. But I'm really curious to learn more about what this means for our understanding of reality.
Yeah, me too. And that's something that we'll dig into more in the next part of our deep dive.
All right, so stay tuned, folks. Things are about to get even weirder. All right, so we talk about how entanglement is this real and kind of spooky thing that really challenges how we think about the universe. But now I want to get into something that sounds like straight up science fiction. Quantum teleportation. Like, how does that even work? And what does it mean philosophically?
Yeah, so it's important to remember that we're not talking about beaming people up like in Star Trek.
Okay, good, because I was getting a little worried.
Yeah, no, it's not about teleporting actual matter like atoms or molecules. It's about teleporting quantum information. So basically, the state of a particle from one place to another without that particle actually moving.
Wait, so how do you teleport information without moving the thing that's carrying that information? I'm so
It was
confused.
kind of mind blowing. Okay, so imagine we have our two entangled particles again, right? Call them
Yeah,
Alice and Bob, just for fun.
sure. Why not?
Now, Alice has another particle, let's call it Charlie, and this particle is in some unknown quantum state. And Alice wants to send this information about Charlie's state to Bob, but she doesn't want to actually send Charlie over there.
So it's like sending a message without the actual letter. How's that possible?
That's where entanglement comes in. Alice performs a special measurement on Charlie and her entangled particle, the one we called Alice A. Now, this measurement, it doesn't tell Alice what Charlie's state is, but it entangles Charlie's state with the state of Alice A. And because Alice A is entangled with Bob B, this measurement instantly affects Bob B's state too, even though they could be miles apart.
Okay, hold on. So Alice does something to her particles over here, and Bob's particle over there changes instantly. But how does that actually send the information about Charlie's state?
So then Alice sends the results of her measurement to Bob using like a normal phone call or email, something like that. And this message doesn't actually contain any information about Charlie's state, just the results of her measurement. But because Bob knows about the entanglement, right, and he gets these measurement results, he can do a specific operation on Bob B that transforms it into a perfect replica of Charlie's original state.
Whoa. So it's like Charlie's state just vanished from one place and reappeared in another without actually traveling through the space in between.
Exactly. It's like the information itself jumped across space.
Okay, this is some serious mind-bending stuff. And it has to have some pretty wild philosophical implications too, right?
Absolutely. For one thing, it makes you really question our ideas about locality. Like, how can information travel without any physical carrier? Does that mean that information is more fundamental than we thought? Maybe even more fundamental than particles themselves.
So are you saying that the universe itself is like some kind of giant information network?
It's a pretty trippy thought, isn't it? And it makes you wonder, like, what is information anyway? Is it just a description of reality, or is it something more fundamental, something that actually shapes reality?
I mean, if you can teleport information, it kind of seems like it has its own independent existence, right?
Yeah, and it raises all sorts of questions about identity and individuality, too. Like, if you can teleport the quantum state of a particle, is it still the same particle? Does it have a unique identity?
This is getting deep, man.
Yeah, and it's not just about teleportation. This whole concept of entanglement really changes how we think about quantum information in general. Like, we're used to thinking of information in terms of bits, zeros, and ones, but quantum information, it's different.
So it's like quantum bits.
Exactly, qubits. And they can exist in this weird state of being both 0 and 1 at the same time, like a superposition. And that opens up all sorts of crazy possibilities for computation and information processing.
No wonder people are going nuts over quantum computers.
Yeah, entanglement is really the key that unlocks the power of quantum computers. It lets them perform certain calculations way faster than any classical computer could ever dream of.
Okay, so entanglement is this powerful resource, but it also raises some pretty fundamental questions about causality. Like, we've talked about how entanglement seems to violate local realism. Does that mean that our idea of cause and effect is just wrong?
Well, not necessarily that it's wrong, but maybe it works differently in the quantum world than we're used to. Some interpretations of quantum mechanics say that entanglement points to a type of non-locality where events can be correlated in ways that our normal ideas of space and time can't really explain.
So it's not that things are influencing each other faster than light,
Yeah.
but that our very concept of separate things might be flawed.
Exactly. It's like the universe is way more interconnected than we ever imagine.
So this deep dive is really making me question everything I thought I knew about reality, but I gotta admit, it's pretty fascinating.
Right. And we're not even done yet. There's still more to explore, like the whole idea of a non-Boolean structure of quantum properties.
You have to explain that one to me. What does that even mean?
Well, it's another area where quantum mechanics really diverges from classical physics and challenges our intuitive grasp of logic. It gets pretty deep, but basically it means that the fundamental building blocks of reality might not follow the same logical rules that we're used to in our everyday world.
All right, so you've really gotten me thinking here. We've talked about spooky action at a distance, this teleportation of information, and how quantum information is so strange and different. And now you're saying that quantum entanglement even messes with logic, like
Yeah.
the very foundation of how we think. I'm not sure if I should be excited or scared. So tell me, what is this non-Boolean structure you mentioned? How does that connect to entanglement?
Yeah, so it's one of those things in quantum mechanics that really makes you scratch your head and go, huh, what's going on here?
Uh-huh.
In classical logic, the kind we use every day, we deal with stuff that's either true or false, right? Like the cat is on the mat or the cat is not on the mat.
Right. Classic Boolean logic, named after George Boole. It's like the bedrock of how we reason and how computers work, right? Ones and zeros, on or off, true or false. But you're saying quantum mechanics doesn't play by those rules.
Yeah, it kind of throws the rule book out the window. Because quantum properties, they can be in these superpositions, which means they can be both true and false at the same time. And that's where entanglement comes in. Because when you've got two particles that are entangled, you can't talk about the properties of one without talking about the properties of the other. They're not independent anymore.
So it's like their logic is all tangled up together. Like it's not just that they're correlated, but that their truth values are somehow linked.
Exactly. And that has some really deep implications for how we understand logic and even reality itself. Because it suggests that the fundamental stuff that the universe is made of might not actually obey the same logical rules that we're used to in our big macroscopic world.
Well, hold on a second. Are you saying that logic itself is different at the quantum level? Does that mean that truth is, like, relative or subjective?
It's not so much that truth is relative or subjective. It's more like our classical logic, the kind that works so well for us in our everyday lives, might just not be the right tool for describing the quantum world. We might need a whole new kind of logic, something called quantum logic, to really grasp the strange connections between these entangled properties.
So quantum entanglement isn't just this weird physics thing. It's making us rethink the language we use to describe reality.
Yeah, I think that's a good way to put it. And it's not just logic that's being challenged either. Entanglement also has some pretty, that's the idea. Some physicists even talk about it from bit, like the universe is made of information, and entanglement is the way this information is all woven together.
Okay, now that's a really trippy thought. So instead of thinking about the universe as made of particles and forces, we should be thinking about it as made of information. And entanglement is how that information is connected.
Yeah, it's a pretty radical idea, but it's one that's gaining some traction among folks who are trying to make sense of all this quantum weirdness.
I can see how this would be really appealing to philosophers, right? It's almost like saying that the universe is one giant cosmic mind, and entanglement is the way thoughts are connected within that mind.
I like that. And it highlights how quantum entanglement is not just a scientific puzzle to solve, but also this huge philosophical challenge. It's pushing us to rethink our most basic assumptions about reality, logic, and what information really is.
This deep dive has been incredible. We've gone from spooky action at a distance to the very nature of reality itself. It's clear that quantum entanglement isn't just some weird scientific curiosity. It's like a philosophical goldmine.
Totally agree. And the really exciting part is that we've only just scratched the surface. There's still so much we don't know, so many mysteries left to uncover.
Well, thanks for joining us on this mind-bending exploration of quantum entanglement. We hope you've enjoyed the deep dive. And maybe, just maybe, it's made you look at the world a little differently.